Good morning, students. Myself, Vijay Shankar from EC Department, Chevrolet Engineering College. Today, we are going to discuss about the Fourier series examples. We already learned what are the different types of the Fourier series, compact trigonometric Fourier series, and the exponential Fourier series, and the properties, 9 properties of the Fourier series. The linearity property, time shift property, frequency shift property, scaling property, and time differentiation property, convolution in time, modulation in time or multiplication in time, Parseval's theorem, and the symmetric properties. Now we go for some examples on this. First example, you can see find the trigonometric Fourier series. Find the trigonometric Fourier series for the periodic signal shown here. Why they are saying that it's a periodic means it is repeated for every 0.5 the time period. It is repeating the exponentially decaying function. Exponentially decaying function for every 0.5 time period. So here they see the time period t is 0.5 and the given signal is e power minus t. Decaying means exponentially decaying e power minus t over one period. So the trigonometric Fourier series, we know the A of 0 is a formula is 1 by t, or it is a 2 by t. You can replace the x of t is equal to a naught by 2. Otherwise, you can take here the 1 by t directly. Take there it is a naught 1 by t, the integral t x of t dt. So what is the time period here? The time period is a 0.5. Substitute here the 0.5. Integral, the range is also the 0 to 0.5. The initial value is 0 and the final value is 0.5. So 0 to 0.5 e power minus t dt. So e power minus t integral is the e power minus t by minus 1. So minus t e power minus t. Upper limit 0.5 and the lower limit is 0. So 1 by 0.5 is nothing but the 2. For upper limit, take the minus here. Upper limit e power minus 0.5. E power minus 0.5 minus e power 0 minus 0 is a 1. Calculate this value and we'll get e power 0 is a 1 and e power minus 0.5 definitely these are less than the 1 only. Less than the 1. And minus into minus is a plus. It becomes of 0.7869. 0.7869. And for the step 2, to calculate the A of k. A of k, the formula is a 2 by t. The integral t, x of t, cos k omega naught t is the second term of the equation of the trigonometric Fourier series. As the omega naught is equal to 2 pi by t, the 2 pi f, f is inversely proportional to the time period. 2 pi by 0.5. 0.5 is nothing but the 2. So 2 into 2 pi is a 4 pi as omega naught. And A of k is equal to 2 by, the time period is at 0.5. Substitute here the 2 by 0.5. The integral 0 to 0.5 x of t cos k omega naught. What is omega naught? We got the 4 pi. 4 pi t into dt. So what x of t is e power minus t. Substitute the e power minus t cos 4 pi k into t dt. So now it is in the integral of e power minus ax, or it is a plus ax. Let us take the e power plus ax and cos bx into dx. This is a formula. We know that the formula is the integral is already here. See. E power ax cos bx into dx. E power ax by a square plus b square into a cos bx plus b sin bx. Here a is a minus 1 and the b is a 4 pi k. Why? The t is the x here. With respect to the time, we are applying the integral here. The t value is a x and a is a minus 1 and the b is a 4 pi k. Using this relation, apply the integral value and substitute the upper limit is 0.5 and lower limit is 0. So here So A of k is equal to 4. That is nothing but 2 by 0.5 is a 4. E power minus a is a 1. Okay. E power minus when a is equal to minus 1 and the b is equal to 4 pi k. So e power minus 1 plus 4 pi k whole square, a square plus b square it is, into a cos bx. A is minus 1, b is 4 pi k into t, and b sin bx. b is 4 pi k sin 4 pi k into t. Upper limit is 0.5 and lower limit is 0. But my students, e power a into x. A is a minus 1 here and the t is there. Okay. And 4 into e power minus the 0.5. It's not the 0.5, my students. It is e power minus t only. That t as substituted as a upper limit is a 0.5 and minus cos 4 pi k into t is 0.5 and 4 pi k sin 4 pi k into 0.5. So totally the upper limit will get all the t values is replaced with the 0.5. And for the lower limit, minus e power 0, minus 0 or plus 0 both are the same. 1 by 4 pi k whole square minus cos 4 pi k into 0. Why it is a 0 here? The lower limit is a 0 for t. And substituting here the t is there, 4 pi k sin 4 pi k into 0. Got it, my students? So that is equal to e power value is there, the e power minus 4 pi k. And see here the cos 0 and the sin 0. What is the cos 0 and sin 0? So cos 0 we know the value is 1 and sin 0 the value is 0. You see here. So the last here the 4 terms we have. In that 4 terms, the last 2 terms you can observe here. Cos 0 is there, the value is 1. And sin 0, the value is 0. And remaining 2 functions, common term is there here, the 4 and denominator is a 1 plus 4 pi k whole square, total function having. And e power minus 0.5, the e power minus 0.5, the value is 0.606. By using the calculator, you can find out, my students. You'll get e power minus 0.5 is 0.606. Okay. And here the minus cos 4 pi k into 0.5. 0.5 means 1 by 2. And 2 to get cancelled is a cos 2 pi k. Similarly, here also 0.5 is 1 by 2. And the 2 to get cancelled sin 2 pi k. What is the cos 2 pi value? Cos 2 pi value is here the sin 2 pi. Irrespective of the value of k, cos 2 pi is a 1 and the sin 2 pi is a 0. So in this also the function here, the term, the first term is minus 0.606 is multiplied to the 1. And the second term is a 0, 0.606 into 0, the value is a 0. And minus of the function here, the cos 0 is a 1, minus into minus is a plus, and sin 0 is a 0 after simplification. Got it? So 4 by 1 plus 4 pi k whole square, and you can add the functions 1 minus 606, so you'll get some value and it is multiplied with the 4. Totally 1.576 A of k is equal to 1.576 whole divided by 1 plus 4 pi k whole square. The similar way, b of k is equal to 2 by t, the integral x of t sin k omega naught t. Sin k omega naught t, and 2 by 0.5, the integral 0 to 0.5 e power minus t sin k omega naught is a 4 pi into t dt. Okay, the omega naught already we know that it is a 4 pi ohm. And 2 pi by t, the t is 0.5 and you'll get the 4 pi. Again, the formula is there, e power ax into sine bx. E power ax into sine bx. Previously, the e power ax cos bx here. E power ax cos bx into dx. Now it is a e power ax sine bx. Only the change is e power ax by the a square plus b square is the same. And here, the change of the value, only the remaining function. The 2 by 4.5 is a 4, the integral 0 to 0.5, e power minus t is a e power ax sine bx. After simplifying this function, after simplifying the function here, this is a cos ax plus b cos sine bx the function. And finally, the numerator is a constant. The value will get the a of k, and the b of k is not the constant value, it's the variable of k also. The second term, the 6.32 pi k whole divided by 1 plus 4 pi k whole square. Using the formula of e power ax sine bx into dx is equal to. Expand the function and apply the limitations, and then you can simplify. You'll get the 6.32 pi k into 1 by 1 plus 4 pi k whole square. And finally, you can write this expression a of 0, a of k, b of k in the trigonometric Fourier series expression. What is the trigonometric Fourier series expression? X of t is equal to a of 0 plus the sum of k is equal to 1 to n, a of k cos k omega naught t. And similarly, for the sum of k equal to 1 to n, b of k sine k omega naught t. So what is the a naught? We got so a naught is a 0.7869 plus sum of k is equal to 1 to n, or it is infinite up to the value. A of k we got 1.576 whole divided by 1 plus 4 pi k whole square, and it is multiplied with the cos k omega naught t plus, and sum of k is equal to 1 to n, or the infinite value. The b of k, we got the b of k is equal to 6.32 pi k whole divided by 1 plus 4 pi k whole square into sine function, sine k omega naught t. The total trigonometric equation x of t is equal to the combination of a of 0, a of k, and the b of k. Got it? Then you go for the next example, the periodic rectangular wave. Let us determine the Fourier series coefficients, not the trigonometric Fourier series here. You can determine the Fourier series coefficient of the following. The Fourier series coefficient means it is a of 0 and a of k and the b of k only. Not it is of totally the trigonometric Fourier series, simply the a of 0 and a of k value. See, the given function from the graphical representation, x of t is equal to, you see, it is a periodic signal. And it is repeated from minus t bar to the t by 2. Here, see, after minus t bar to the t by 2. Up to that, it is a 0 and is a 1 and the 0. Again, it is repeated here. The same thing. And again, it is repeated here. The same thing. So, the periodic signal with the period of minus t by to the t by 2, or tau by to the tau by 2. Take here the t by to the t by 2 only. The Fourier series coefficient or a suffix k is equal to 1 by t, the integral t, the t is minus t by to the t by 2, x of t into e power minus jk omega naught t dt. What is the x of t? X of t is only the having the magnitude is a 1, and here it is a 0, and this value is also 0. So it is total region from minus t1 to the t1 only, the value is 1 of x of t. So that rewrite the function as 1 by t, the integral minus t to t1 to t, minus t1 to t1 plus t1. The x of t value is 1, e power minus jk omega naught t dt. Apply the integral of this function, 1 by t, the e power minus jk omega naught t pi, the t coefficient is minus jk omega naught. So minus 1 by jk omega naught into t, total function. So e power minus jk omega naught t, upper limit is a t1 and lower limit is a minus t1. So substitute the t as a t1 here, and the lower limit is a minus t1. So whenever it is a minus t1, the exponential value becomes a positive. And whenever the positive value is a negative, and here the minus is there outside, multiply that minus, the positive exponential becomes a positive and the negative exponential becomes a minus. Got it, my dear friends? Okay. And in the denominator, there is no any 2j to write it as a sine function. Already the j function is there, multiply the 2 and the 2 in the numerator and the denominator. The total function becomes sine j into x. What is the x value? K omega naught t1. So 2 by k omega naught t and sine k omega naught t. So finally, the a of k is equal to 2 sine k omega naught t1 by the k omega naught t, capital T only. Got it, my dear students? Numerator is a t1. Why? We know the sine x is equal to, e power jx minus e power minus jx by 2j. Okay. So in this here, there is many denominator, so I multiply and divide with the 2 to bring the function as a sine function. And instead of x here, there is a k omega naught t1. So sine k omega naught t1, and denominator is k omega naught t. The denominator we read already when I was applying the integral of e power jx. That coefficient is there, k omega naught capital T is. When the k is equal to 0, the Fourier series coefficient, we derive the k not equal to 0, that is a of k. If k is equal to 0, then the value becomes a0 is equal to 1 by t. The next example here, periodic impulse train. Consider the impulse signal. Consider the impulse signal or impulse train. X of t is equal to sum of k equal to minus infinite to infinite, delta t minus k into t. The fundamental period of x of t is a t. The Fourier series coefficient is a of k 1 by t, the integral minus t1 to the t2 delta of t dt. This total function, the value is a 1, impulse train. So the a of k is equal to 1 by t1. Even if it is a of 0 is also the same thing, will get the 1 by t. Nothing is a difference. Got it? And other examples we have. Now another example, The same thing, determine the trigonometric Fourier series for the ramp function. The ramp function here. See, the x of t, the given as 0 to t, it is again repeated for every time period of the t. So a0 and the an and the bn you have to find out for the trigonometric Fourier series. The formula is a 1 by t. The integral 0 to t, why it is a 0 to t? The range is 0 to t, and it is a ramp function. Ramp function means the t value is there, the t. So before that, you can find out the slope equation also. So y2, y minus y1 by y2 minus y1, and x minus x1 by x1 minus x2. Okay, that y is x of t and x is the t function. The t variable is there. And the y-axis, there is a x of t signal, and in the time period, that is a t. Got it, my dear students? So the ramp function, the y2 minus y1 by, or the y minus y1 is equal to y2 minus y1 by x2 minus x1 into x minus x1 is a formula we have to find out the slope equation. y1 means it is a value is at the 0 and the y2 is a in the y-axis. y1 and the y2 the two functions, the coordinates of p and the coordinates of q is there here. The t1 is a 0 and xt1 is a 0, and the t2 and x of t2, the capital T here and the capital E, the two functions, x1 and x2 and y1 and y2. So y minus y, what is the y here? The x of t minus y1, the value is a 0, is equal to y2. y2 value, what is the y2 value? Is a minus y1, the value is a 0, by x2, here it is a t, and x1, the value is a 0, t minus 0, into x value is a t, the variable is a t minus x1 is a 0. Okay. y1 and y2 and x1 and x2. So y1 value is a 0 and y2 value is a in the y-axis, see the 0 and a, and x1 and x2, the values is a 0 and the t. So by substituting these functions, these coordinates in this equation, we'll get x of t is equal to x of t minus 0 here. X of t is equal to a by capital T into small t. This is the slope equation. See, the x of t is equal to, we got a t by the capital T from 0 to capital T on the range of the slope. Up to this only, I find out the equation. So the evaluate of a of 0 is equal to 1 by t and the integral 0 to t x of t dt. What is the x of t here? We got a by the capital T into t. The a by t is a constant value. So a by the t already there, t square, integral 0 to t, the t into dt. The integral of t is a t square by 2. Upper limit is t and lower limit is a 0. So when substituting the upper limit t square and substituting the lower limit, it becomes a 0. So denominator having the t square and denominator having the t square, we have only the a by 2 is a a0. A by 2, the capital A by 2 is for the a0. Similarly, here you can find the next one is a an. an is equal to, what is the formula? The 2 by t, the integral 0 to t x of t cos n omega naught t. You can replace the n omega like this or the angular frequency, both are the same. For to show the representing of omega naught for the continuous time function and the discrete time function. For discrete time function, we have used the angular frequency omega naught. Both the formula is the same. Omega naught is equal to 2 pi f only. Okay. And see the an is equal to the 2 pi t here. 2 pi t. An is equal to 2 pi t, the integral t. Integral 0 to t x of t cos n omega naught t dt. What is x of t? A t by capital T cos n omega naught t dt. And a by capital T is a constant. Already we have the 2 by t, 2a by t square is a constant. Now, the integral is only for the two functions, 0 to t, tn cos n omega naught t, n omega naught t dt. Now you can see these two are the UV rule. But the first one, if I am taking the t into integral 0 to t cos n omega naught t dt minus the derivative of t, or the integration by parts I am applying here. The derivative of t is 1, and cos n omega naught t, the integral is sin n omega naught t, and the t coefficient is n omega naught into dt. Upper limit is t and the 0. Again, inside there is another integral is there, integral sin. So 2a by t square, small t. The integral 0 to t is sin n omega naught t by n omega naught t minus. The integral of sin is a minus cos. Minus cos n omega naught t by n square omega naught square. That is the second time we are applying the integration. The t coefficient again will get n square by omega naught square. Capital T and the 0. Now substitute the upper limit and the lower limit in this equation wherever the small t is there. First of all, I am taking the capital T, t sin n 2 pi by t and the capital T, and 2 n omega naught is at 2 pi by t only, plus cos n 2 pi by t, then think what is omega naught into capital T. N square omega naught is nothing but 2 pi by t, that is a whole square, pi 4 pi square by t square, minus, and the 0, the second, the lower limit you can substitute. Here the t is there, the total term is a 0. And in the cos of, there is a function, the t, cos 0 value is 1. You'll have only the denominator, that is n square 4 pi square by t square. So simplify this function. T into t is there. The t into t, it's not the t square here, my dear students. This is a sin n into t. Sin n into t. Okay. Sin n into t, and this is not the t square, it's a t only. By, and this function, okay. This t will get in the numerator. Here the t is there. That is the t square. T square by 2 pi n sin 2 pi n into this t is there. And next function is there, the t square will get the numerator, and 4 pi square n square cos t get cancelled here, cos n 2 pi minus 0, and the denominator, the t square will get in the numerator, t square by n square 4 pi square. Okay. And now you can see sin pi n into 2 pi is always a 0. Cos 2 pi, the value is a 1, irrespective of the multiplication factor of n here. Cos pi is a 1, cos 2 pi. Cos 2 pi is a 1, and the sin 2 pi is a 0. Sin 2 pi is a 0 means the first term becomes a 0. Eliminate this one. And already third term is eliminated. And cos n 2 pi, the value is a 1 here. Replacing this total function as a 1. So t square by 4 pi n square, pi square n square, and here the minus t square by 4 pi square n square. Both are is a plus and minus, again it's used to cancel, and you will get the only 0. So the second an is the value is a 0. Similarly, the evaluating of bn, Bn is equal to 2 pi by t, not the 2 pi by t, the 2 pi t, the integral 0 to t x of t sine n omega naught t dt. Substitute the x of t, a t by t, a small t by capital T. And now it is in the UV rule. T, apply the integral of sine, that is a minus cos n omega naught t by n omega naught, minus the derivative of t is a 1. Again, the integral is a sine is a minus cos n omega naught t by n omega naught t dt. And inside there is another integral you can apply, that is a minus t cos n omega naught t by n omega naught, and minus into minus is a plus. For the integral of cos, again the sine function will get sine n omega naught t pi. For this also there is a coefficient of n omega naught. Already there is n omega naught, the square of n omega naught whole square. Upper limit is a 0, the lower limit is a, upper limit is a t, sorry, and lower limit is a 0. Now simplify by substituting the t value here. Wherever the small t is there, replace the capital T and the 0. The first term is a t, first two terms, and the next two terms is a 0 and 0. Sine 0, the value is a 0. So last two terms is a 0, get cancelled. And here the t and t get cancelled. It becomes of t square minus t square by 2 pi n. And here also they will get the t square in the numerator, t square by 4 pi square n square. And tt get cancelled. You know the cos 2 pi and the sine 2 pi. Sine 2 pi is a 0 again. Cos 2 pi is a 1. So 2a by t square, 2a by t square is multiplied with the cos coefficient only. Already the sine is becomes a 0. The second term is a 0. And we have only the minus t square by 2 pi into n. 2 get cancelled, t square get cancelled, and finally the minus a by n pi, minus a by n pi. Got it, my student? Then the Fourier series, trigonometric Fourier series, x of t is equal to a naught plus, the cos function becomes a 0 because an is a 0. An becomes a 0. A naught is a by 2. Okay, a by 2 plus, and this is sum of n is equal to 1 to infinite. The bn we got as minus a by n pi, minus a by n pi into sine n omega naught t dt. So actually the formula is x of t is equal to a naught plus sum of n is equal to, here they are taking that n is equal to 1 to infinite an cos n omega naught t plus sum of n is equal to 1 to infinite bn sin n omega naught t. So what is the an? We got the 0. So second term, there is no any second term. We have only the first term. The first term value is a by 2 we got. A naught is a by 2 plus sum of n is equal to 1 to infinite. What is a bn? Bn is a minus a by n pi, minus a by n pi into sine n omega naught t. Now you can expand with the n is equal to 1. The first term becomes minus a by pi sine omega naught t. That n value is a 1. Second term becomes minus a by 2 pi sine 2 omega naught t. And third term becomes a by 3 pi sine 3 omega naught t, and so on. This is a trigonometric Fourier series for the given sawtooth waveform in the range of 0 to t with an amplitude of a as a signal is a periodic signal. Got it, my students? This already we've seen in the first example 0 to 0.5. We got One thing is a 1.576 pi 1 plus 4 pi k whole square, and the second b of k is a 6.32 pi k and 1 by 4 pi k square, and a naught is equal to 0.7869. Okay, we'll got the trigonometric Fourier series and the polar form. The next class we can see.